All right, we're doing the same thing here, except obviously these are getting a little bit more complicated. These actually tell you to solve by factoring. All right, so if I'm factoring this out, I wouldn't treat this any different than if it looked like this. So basically what I'm looking at here is a trinomial that I need to factor. And you can use your reverse FOIL method or whatever method you use in order to factor that. But if I were factoring that, I would break this factor down into this term down into 2x times x, and then that's got to be 1 and 1, and the biggest sign has got to be negative, because when I FOIL this back out, when I multiply this back out, my middle term's got to be negative. Alright, so I'm not doing anything different in this particular problem than I did here, except x in this case is going to be sine of theta. So when I factor this, this is going to be 2 times the sine of theta plus 1 times the sine of theta minus 1. And you can check that. Multiply that back out and make sure that you get what you started with. Alright, now I'm applying the zero product property, which tells me that if I'm multiplying to get 0, that one of these factors has to be 0. Alright, so if I set each factor equal to 0, and then I solve, just like I did in the earlier problem. So I forgot to set that equal to 0. When I isolate my sine of theta, I'm going to subtract 1. And then divide by 2. So the sine of theta is going to equal negative 1/2. Alright, and now you're starting this whole process over. You're thinking, alright, my sine, my exact value is negative, which means I'm looking at quadrants 3 and quadrants 4 for my values. I know that the sine of 30 degrees is 1/2. So my angle coming out of the third quadrant is going to be 180 plus 30, or 210 degrees. All solutions, I'm adding my 360 times my integer. In quadrant 4, it's going to be 360 minus 30 degrees, or 330, plus all solutions. So there you go. Okay. Alright, going on to 48, I'm doing the same thing. If you need to write it in terms of x to factor it, go for it. Alright, so I'm got to break this down. Alright, so now I'm looking for two numbers that multiply to give me 12, and unlike the first one, this one was pretty easy because I had 1. I don't have any options for 1. 12 is a little bit more complicated because you've got all kind of options for that. You've got 1 and 12, you've got 2 and 6, you've got 3 and 4, in any of those combinations. So you have to be careful there when you're factoring. Alright, so if I'm factoring this, I'm thinking, and you can just play around with it, so I'm thinking, let's just try 3 and 4. When I multiply this out, I get a 3 and an 8, and I need that 5 to be positive, so that's going to have to be positive, and that's going to have to be negative. See, when I multiply this back out, I get 2 times sine of theta times sine of theta. There's my 2 sine squared of theta. When I do my outside, that gives me positive 8 minus 3, which is my positive 5, and then I've got a negative 3 times positive 4, which is negative 12. Alright, so that's how this factors. Now, when I set both of these factors equal to 0, and solve them, I'm going to isolate that. So the sine of theta is going to equal 3 over 2. The sine of theta over here is going to equal negative 4. Alright, so let's just look at this one first. This is asking me the sine of what angle is 1.5. Alright, so at that point there should be a little red flag or a little bell going off in your head, and you should remember that our range, when we plug in any value for sine, our domain is any real number. When we plug it in, we get values between negative 1 and 1. Well, this is saying, what value can I plug in here and get 1.5? Well, that's over 1. So that's not going to happen. Alright, same thing over here. The sine of what angle is -4? Well, I'm never going to get anything out of here that's less than -1. So that doesn't work either. So in this case, there's no solution. Okay? Can't get my paper. Cooperate. Alright, let's keep going. Let's see if I can get these two in. Alright, this has actually already been factored for us, so I'm going to use my zero product property and just go ahead and say the secant of theta equals 0. The 2 times the cosine of theta minus the square root of 2 equals 0. Alright, we know that can't happen. Alright, so we're not worried about that factor. When I isolate my cosine of theta here, I'm going to add the square root of 2 and divide by 2, so I know that cosine of theta equals positive square root 2 over 2. I know that I'm looking at quadrants 1 and 4 for those angles. And I know that the cosine of 45 degrees is the square root of 2 over 2. And if I want all solutions, I'm adding 360 degrees times an integer. Or out of that fourth quadrant, I'm adding 360 degrees to 315 to get all the solutions there. Alright, I'm going to do one more. So 54 is the tangent of theta times the sine of theta plus the sine of theta equals 0. So if I'm looking at that, I'm looking at this term and thinking, can I factor this? And yes, I can, because they have a common term. So I'm going to factor out that common factor. And when I factor the sine of theta out of this first term, I'm left with the tangent of theta. When I factor out a sine of theta from the second term, I divide by sine of theta, or divide by itself, I get 1, and don't forget to write that 1 because it's not 0, it's 1. Alright, and then I'm looking at the sine of theta equals 0 as one of my factors, and I'm looking at the tangent of theta plus 1 as my other factor, so I'm setting both of my factors equal to 0. And here, the sine of theta equals 0. Alright, let's think about that. The sine of 0 is 0, so I know 0 works. Alright, what else would work? Well, 180 degrees would work. Alright, now how can I express this so that all solutions are covered? Well, I know that this is a solution. I also know that this is a solution. Alright, so I could keep going around and around. And so really the easiest way to express this, now if you wanted to do 0 plus 360 times n, and then 180 times 3 plus 360 times n, you can certainly do that because that's true and that makes it, but actually the most concise way or the easiest way to do it would just to be expressed as 180 degrees times n. Because if you think about that, if I let n be 0, that's 0. If I let n be 1, there's my 180. I let n be 2, I'm back here, and so on and so on. Okay? Alright, that was just half of that. Now I'm going to do my other factor. So tangent of theta equals -1. What two quadrants is this coming out of? Well, that's coming out of quadrant 2 and 4. Alright? And I know that my reference angle is 45 degrees. I've actually already done a problem that's got the tangent of theta equal 1. So this is just -1. So that's why I'm looking at quadrants 2 and 4. Alright, so out of quadrant 2, I'm doing 180 minus 45 degrees or 135 degrees. And you can figure that out, but you don't need to with tangent because you know that if you add 180 degrees times an integer, that's going to give you